Hello students, welcome back. Now we are going to talk about one very interesting application of finite state machine, and that is pattern detector. So in this video we are going to talk about that what is a pattern detector, what is the concept on which these circuit works. We are going to design one FSM for our pattern detector and implement it using Verilog. So let us get started. So first of all, the question that we have is what exactly is a pattern detector? I have a bit streams of zeros and ones. Some random zeros and ones are coming for infinite duration. We are given the restriction that in one clock cycle, one new bit is coming at the end of the sequence. That means the sequence is always updated. Our aim is to detect or recognize some patterns. Like I am interested in finding 0111 or 1011 or 10111, anything like that. So in that infinite stream, we have to detect the presence of these patterns, and whenever the detection or the recognition is done, we will indicate in our output by showing the output value as 1. So whenever we recognize, output flag is raised to 1, otherwise the output remains 0. So here let us first visualize that what is going to happen. Consider that we have the following bit stream and we aim to detect only 1011. So here we have some numbers, maybe 20 or more than that, and we start scanning by our eyes and we can see that here is the first pattern. Then we move ahead and we find that here we have one more such pattern. Then an overlapping pattern is found. So here we got our third detection. We move ahead and we find one more. So there are 4 places at which we are able to detect the pattern 1011. So here we can see that we are able to detect the pattern 1011 for 4 times. So the output that we have is going to be having value 1 at these 4 places at the end of pattern. Whenever we detect at the end of the pattern, the output will be 1, otherwise the output will remain 0. Now this is something very similar to the FSM example that we had, where we were covering the odd or even number of A's and B's. Here also we are doing something in the similar way but for more number of bits. That means this system can be designed with finite state machines. So how to do that, let us explore. Now we are going to design our finite state machine. I have listed down some of the states here, and let us start constructing our finite state machine now. So first of all, I have S initial. That means when nothing is detected. Okay, 0 detection. That does not mean 0 bit detection, but that means nothing from this part is detected. Now I have 2 options, whether the next number will be 1 or 0. If I get the number 1, then I get this, which is useful for me, and I say I will go to this state S1. But if I get 0, then I say I will remain at the same state. When I am at S1, the next bit that I need is 0. So if I get 0 as my input, I go to a state called S10. That means this much part of the pattern is detected. But if 1 is detected, what should we do? Should we go back here? Well, no, because if you see, if I have a 1 and if I get one more 1, I can still use this one in a hope that next time 0 can come. So I will come back here. Now we are at 1 0, and if I get input as 0, that means 1 0 is followed by 0. This thing is not part of my pattern, and we are going to go back to S initial. But if I get 1, then I have 1 0 1, which is part of my pattern, and I go to a new state called S101. Now we are at S101. If I get input as 0, 1 0 1 followed with 0, this is not our pattern, but this much is a part of our pattern. So we will go back to this place. And if I get 1, that means 1 0 1 1, then I go to this state where we can say that output is no more 0, output will be 1. Once we are at 1 0 1 1, the input will still keep on coming. If the input is 0, that means 1 0 1 1 0. This is still useful. Okay, so in that case we will traverse here. And if the input is 1, that means 1 0 1 1 followed by 1, then I can use this 1. So in that case we are going to traverse here. So state transitions are very important. This is what as a designer you have to do. If you don't make your state diagram in an optimized way, your system can have bugs. So once the state diagram is ready, then you can go for the next step, and those are implementations and all. So now we are going to code this machine in Verilog. So here is the code. What are we doing here? We are having FSM pattern using Moore's machine. Input is D in, which will be our input stream, zeros or ones. There is a clock, there is a reset, and the output is Z. We are declaring that D in, clock and reset, these are our wires, and output is Z, which is a register. We are defining the parameters. There are states S initial, S1, S10, S101 and S1011. These are the 5 states. If I have 5 states, I need minimum 3 bits. So that is why they are given the codes in 3 bits. You can decide your own code. I have decided the codes as 0, 1, 2, 3 and 7. You are free to choose any 5 codes. Then I define 2 more registers. One is state and one is next state, and both of them are also 3-bit. Then we start our coding. First of all, we declare the reset case. We say if reset is equal to 1, then the state will go to S initial. Otherwise, the state is next state. Next, we have our main code. We are saying case state. In S initial, if input is 1, we go to S1. Otherwise, with input is 0, we go to S initial. In S initial, the output remains 0. When we go to the next state, and that is S1, if input is 0, we go to S10. And if input is 1, then we roll back to S1 and output remains 0. We have the next state, which is 10. In 10, if input is 1, we go to S101, and if we get 0, that means 100, we roll back to S initial. Output is still 0. In 101, if input is 1, we go to 1011, but if input is 0, then we go to 10. Output is still 0. In 1011, if the input is 0, we will go to S10, and if input is 1 we will go to S1. Output is 1 this time. So that is the code. And one thing that we should do in the case that in case there is any disturbance in the state transitions, then the default will be considered, and we are saying the default state is S initial. So this is our code. Now let us run the simulations. The simulations for a pattern detector need to be done very carefully. First thing, define the clock, which is 0, 1, 100 nanosecond. Then, very important, put reset signal equal to 1 and run for 1 or 2 clock cycle. Our 1 clock cycle is 100 nanosecond, so I am running it for 200 nanosecond. What happened because of that? We got a clear value for Z. It is not X anymore. Now we give certain value to D in. We are saying let me give 1, and now this is the most important thing. You will run the simulation only by setting reset equal to 0 and for 1 clock cycle. What is the clock period? 100 nanosecond. So run it only for 100 nanosecond. Okay, I run it. Now you can see state is changing. After 1, I want to give my input as 0. So I set it 0 and run for 1 more clock. After 0, I give my input as 1. I am only changing D in, nothing else, and run for 1 more clock and then 1 more clock, and you can see at this point Z is 1. If I run for 1 more clock, Z is back to 0 and state transitions are happening. So we will randomly give these bit streams and run for 1 clock at a time. Okay, so I again give a number 1, then I give a number 0, then I give the number 1 and run it. Now let us look at the waveforms which are being generated. So have a look here. We started initially, D in is undefined, so our state is 0. 0 means S initial. At every rising edge, it will look at the value of D in. Now D in is 1, so state is changed at this rising edge to S1. Next time we get 0, so it goes to S10. Next time it is 1, so it is S101. And next time when it look for one more 1, so 1011 is detected and output is 1. This is 1011. Now if I give one more 1, we are back to state S1. And this way we keep on finding for these pattern, and one more pattern is found here, which is 1011. So whenever we detect the pattern, output is 1, otherwise the output is 0. So students, now we know that how to implement certain complex systems also using finite state machine. We are going to implement one more such system, and that is up-down counter, in our next video. Keep learning. Thank you.